In this video on trig graphs, we are going to look at changes in amplitude and period. What I'm going to do to start off with is I'm just going to draw a regular sine x graph. So at this point here would be 360, this point here would be 180, my maximum occurs at 90 degrees, my minimum occurs at 270 degrees, my max value is 1, my min value is -1. So this is a graph of y equals sine x degrees. Okay, let's imagine though we were asked to graph something different. Let's imagine we were asked to graph y equals 2 sine x degrees. If we were to really examine what this means, it essentially means that we've got two lots of sine x. And if we apply this to our maximum and minimum values, if my maximum value of sine x is 1, if I've got two lots of that, 2 lots of 1 is 2. So this simply means that my maximum value is going to be 2. My minimum value is going to be -2. Everything else stays the same in terms of where it cuts the axis and where it finishes. So what we're going to do is we're just going to have a wee go at drawing y equals 2 sine x. Okay, so the only thing that is changed when I've got a number in front of my trig function is the amplitude, and the amplitude is the distance from the midpoint to the highest and lowest points on the graph. So here, for example, the amplitude is 1 from the midpoint of the graph and the maximum value. So all we've done is we have altered the amplitude. So now the maximum is 2, the minimum is -2. Okay, so it just goes steeper, it's stretched. Okay, it still crosses at 180 and it still finishes at 360 degrees. The same rules apply for the cosine function. So the cosine function would start at 1 and have a minimum point at -1 as well. So it would have a maximum value of 1 and a minimum of -1. But if we were asked to sketch y equals 5 cos x degrees, for example, the only thing that changes is the amplitude. The only thing that changes is the maximum and minimum value. The shape stays the same. Okay, so instead of this point being 1, like it would normally be, this point here would be 5 lots of 1, which is 5. Instead of this point here being -1, it's 5 lots of -1, which is -5. The points on the graph remain the same. This point here would be 90 degrees. This point here is 180 degrees. This point here is 270 degrees. And this point here, if we were to bring it down, is 360 degrees. So the number in front of our function changes the amplitude. So here we've got 5 lots of cos x, so it's just a maximum and minimum is affected. The period remains the same. The period simply means how many revolutions are there within 360 degrees. So here we can see that there's 1 revolution of cos, so the period of this function is 1. However, what if we want to investigate something else with the period? The period means how many revolutions do we have in 360 degrees. And how we know this from the graph, like say for example we had the graph of y equals sine x degrees. And let's compare this to the graph of y equals sine 2x degrees, which is different to 2 sine x. This is obviously in a different form. Note here that in this example I've got a 2 in front of the x. This one here I don't have a value in front of the x. When we do not have a value in front of the x, it just means that there is a period of 1, i.e. 1 revolution of the given graph in 360 degrees. But see how we see this 2 here in front of the x? That means that we are going to see 2 revolutions of the sine graph in 360 degrees. Let's show you what I mean by that. So the sine graph starts at 0. That is your sine graph. That is 1 revolution of sine. But we want to have 2 revolutions of sine in our 360 degrees. So we're going to carry this on to this point here. Okay, so I've got 1 revolution here, 2 revolutions here. So the period is how many revolutions there are within the 360 degrees. So after 1 revolution would be my halfway point, which would be here. And the other points of interest here would be the 90 degrees and the 270 degrees. The maximum and minimum values are not affected by the period. Okay, so what we've done here is that we've drawn 1 sine graph, or 1 revolution of sine, but then we had to draw a second revolution because we were asked to graph y equals sine 2x degrees. That means I wanted 2 revolutions of sine in 360 degrees. Okay, let's expand this a wee bit further just to show that the same applies for cos. Let's imagine we've got cos of 3x degrees. That means that the number in front of the x determines how many revolutions of cos that we are going to see in 360 degrees. So this one here is 3, so I'm going to need to draw 3 cycles of cos. 1, 2, 3. I'm just going to extend my graph. So my first cycle of cos to here, my second cycle to here, my third cycle to here. So this point here is 360 degrees. The halfway point, so this would be like, so 1, 1.5. So this point here would be 180 degrees. The maximum and minimum values remain unaffected, 1 and -1. So this is my x and my y axis. Okay, so we have got 1 revolution up to here, 2 revolutions to here, and my third revolution. So the number in front of the x determines how many revolutions there are of the trig function in 360 degrees. What we can do is we can actually combine problems with both the amplitude and the period. So here I've been asked to draw y equals 2 sine 3x. So what does this mean? This means that the maximum and minimum value we need to times them by 2. This means I'm going to have 3 revolutions in 360. 1, 2, 3. Here's x and here is y. So what changes here is that instead of having a maximum and minimum value of 1 and -1, this number here changes the amplitude, so it's going to be 2 and -2. The 3 in front of the x tells me that I've got 3 revolutions of sine in my 360 degrees. So my first revolution finishes here. My second revolution finishes here. If we were asked the question, what is the period of this graph? What is the period of this graph? The period states that, if you were asked what is the period of a graph, essentially is asking how many degrees does it take for the function to do one revolution. And we can see in this example, the period of this graph is 120 degrees, because there is one revolution of our sine graph in 120 degrees. Every 120 degrees, we have a new sine graph. More generally, if we were given a trigonometric function of the form, let's just imagine it was in sine form, y equals a sine bx degrees. If we were asked to state the period, to calculate the period, all we do is we do 360 degrees divided by b. We do 360 divided by this number here. For example, to obtain the period of 120 degrees, we did 360 divided by the number in front of the x. 360 divided by 3, which was 120 degrees. So if you were asked the question, what is the period of the graph, that just means how many degrees does it take for one revolution. We're just going to look at one more example, but we're going to look at it in reverse. More often you will be asked to, or you could be given a graph and asked to be put it in the form of y equals a sine or cos bx degrees, for example. Okay, so what you need to look for in order to do these questions is you need to look at the graph. First thing to note is that our maximum and minimum are not 1 and minus 1. Our maximum and minimum are 6, and that should be at minus 6. Okay, so that means that to start off with, I can say that it's going to be 6 cos something. Okay, because the amplitude has changed by a factor of 6. Now to determine the b, remember, this tells us how many revolutions we have in 360 degrees. So here we can see that we've got 1 revolution, 2 revolutions, and so my graph would be y equals 6 cos 2x degrees. Thank you very much.